Now comes a very popular confusion among students. That is, to sine or cos, that is the question. I want to take the equation of motion in a simple harmonic case, the displacement function, as a sine omega t plus phi or a cos omega t plus phi. Well, both are harmonic function, both have the same periodicity, and actually the cosine function is only shifted by a certain amount of phase compared to sine function. But let me just illustrate it with a proper example. The proper example that we are seeking is the same block spring system. This is the block M with mass M, and it is shifted by a certain distance A and released. Remember, if we want to take the initial condition, the initial point as the middle point, that is the mean position, and we tell that at t is equal to 0, x is equal to 0, you have to take the equation x is equal to a sine omega t plus phi. This is x is equal to a sine omega t. Basically, you see here, if you put the initial condition t is equal to 0, then x turns out to be 0. So, if you are given a problem where there is a spring and it is told that at the start of the motion, the spring, the mass was at the equilibrium or the mean position, this is the equation of choice, a sine omega t. But this same block spring system can be described by taking the time or the starting time at the right extreme position. For example, I extend the spring here and then leave it here. I count my time from here. In that case, at t is equal to 0, x is not 0, but x is a. This is our initial condition. In that case, you should take the equation x is equal to a cos omega t, because if you put t is equal to 0, at t is equal to 0, x becomes a cos 0, which is a. But this is the difference. Depending on the initial condition, these are the equation of choice. But really, if you take either way, it won't matter. For example, suppose you are given the condition that the block is at the right extreme and at t is equal to 0, x is equal to a. At t is equal to 0, x is equal to a. Then you want to describe the displacement function as x is equal to a sine omega t. Please note that this is not the general equation. The general equation is x is equal to a sine omega t plus phi. Now take this, at t is equal to 0, x is a. So put x is equal to a and put t is equal to 0. What do you get? Suppose I take this equation for this, although my choice should have been this, I take this equation, then at t is equal to 0, x is equal to a. So I put t is equal to 0 here, then I get a is equal to a sine 0 plus phi, which means sine phi is equal to 1. And where do I get sine phi equal to 1? When I put phi is pi by 2. This implies that phi is equal to pi by 2, or say 3 pi by 2, like that. So you take the example of pi by 2, you will find that this equation boils down to x is equal to a sine omega t plus pi by 2, because this pi by 2 is my initial phase. So if I put pi by 2, then this a sine omega t plus pi by 2 is what? A cos omega t. This is the situation. A cos omega t. So you see, even if I take this equation, I'll end up with this equation, and this equation are separated by a phase constant of pi by 2. So the equation of choice can be anything, but it basically describes a particular initial condition for a convenient calculation. If x is 0 at t is 0, take a sin omega t plus phi. If x is a at t is equal to 0, take a cos omega t plus phi for the simplicity part of it. If you graph these two functions also, suppose you have taken a sin omega t, then what do you get? You get this graph. This is graph of a sin omega t. What is the graph of a cos omega t? When it is 0, it was a. So this is t is equal to 0, x is equal to 0. This is t is equal to 0, x is equal to a. So you get a graph like this. This is a, this is minus a, this is a. So at t is equal to 0, you see at t is equal to 0, it was 0, whereas it is a. So this is graph of a cos omega t. This all is t by 2, t by 2. This is the sine function, this is the cos function. The cos function looks like a garland. The sine function looks like a snake. So that is how you describe this confusion. There is really no confusion. It is simply a matter of phase difference. In fact, what is this cos curve? It is actually advanced by an angle pi by 2 from this. So this is one area where students get confused, because ultimately if x is equal to a sin omega t, you get a different value than a cos omega t. It is not the same if you just put it blindly. The question is to get back to the initial position and what physical description of the block or the mass or whatever body that is executing SHM is.